Welcome back, everybody. Today we are going to be talking about atoms in general, and focusing on the helium atom. If you remember in the previous tutorial, we spoke about the structure of the atom and we discussed the hydrogen atom and how hydrogen had a singular proton at the center, the only atom that doesn't have a neutron at its nucleus. And we discussed how that was being circled, orbited by an electron. And brief thing there, here it is, my horrible line diagram to the sketch I've actually done in the other slide. But you can see here that's the basic one. If you remember from this as well, another takeaway is that an atom is largely empty space. And if you remember my analogy, or the analogy of my ex-chemistry teacher, we took a garden pea, we put it at the center of Wembley Stadium, and the electron is represented by orbiting all the way around the outskirts of Wembley Stadium. So you can play around with those scales all you like. I think somebody even put it up to about the size of a golf ball, and that would be the centre of Oxford, with the electron orbiting around the Oxford city centre kind of thing. I saw the scale anyway, but moving on. So here we are looking at a bit of more of a prettier diagram. I thought this would be a bit easier for people to read and digest. So what we have got here, and please forgive my color palette up there to the left. I built that as a means of easily coloring things moving forward, keeping things standardized. So that's not part of the presentation. All this here is. So what we've got here is the helium atom, and helium, as we all know, is a gas. It's filled with. See up there is it's my son's 11th birthday, and it's holding those balloons up there. So just a little digression that it's used for that purpose. Anyway, so helium itself, what makes it different from hydrogen in it? Well, the key thing is that extra proton at the center. So whereas hydrogen has got the single proton at the center, helium has now got two, and it's now joined by two neutrons. So two neutrons have come into the play, and they've joined the two protons that we see here, and they now form the helium nucleus, the nucleus of the helium atom. And as far as electrons go, again, as you might expect, we've increased the protons. We also increased the electrons. We've now got the two electrons up there orbiting around the nucleus of the helium atom. So what can we deduce from that then? Well, let's have a look at how we put this together into the science talk. So we have now got 1, 2, 3, 4 particles at the nucleus of helium that make up the atomic mass. So that is the two number of protons plus the number of neutrons down below that makes up the atomic mass that we can see here. And then we've got the atomic number, which is the number of protons. So obviously, if you take the number of protons from the atomic mass, that also gives you the number of electrons. But by and large, well, the number of protons will equal the number of electrons in an atom anyway. If you start changing those ratios, then you end up with charged particles, which we'll discuss later. But by and large, all you need to take from this is the helium atom. This is the symbol. So whenever you look at this, that's going to be the atomic symbol there, He. That could just as easily be the hydrogen as we saw previously, or it could be oxygen, O for oxygen, or it could be Li for lithium, and so on. And so the left, this is what you've got, the atomic mass to the left, which is the number of protons and neutrons in the nucleus. And we've got the atomic number, which is 2, and that denotes the number of protons there are in the nucleus. And that also tells us how many electrons there are. So moving forward, that is pretty much how this chemistry works. So moving forward, we're going to be looking at the periodic table now and seeing how the periodic table works. So please join us for that lesson and more as we move on to the periodic table. Thank you.